Welcome back, Nature in Code. We are in chapter 5 and we have just implemented this function here, init_grid, which initializes our two-dimensional grid, and we have initialized the population with the three different genotypes at Hardy-Weinberg frequencies. So what we would like to do now is we would like to now implement the simulation, meaning that we will have to implement many generations and see what happens throughout the generations. So what I'm going to do here after I've called this function init_grid, I'm simply going to start a loop here that says for var I equals 0, and then I'm going to iterate here 100 times, and then of course I equals I plus 1. And then I'm going to call a function run generation. And of course I'll have to define this, but this is now basically just a loop that will run the generations. Now I'm hard coding this here as 100. As you probably know by now, I'm not a fan of hard coding these values in the loops, I'm going to change that later. But for the time being, that's just okay. So let me define the function run generation. Now we have to think about, okay, what should happen at each generation? Well, we simply want the following process. We want to go through each individual, and then for each individual, we want to pick a random mating partner in the allowable mating, or from the allowable mating neighborhood, given this constraint of the mating distance. Because that's the whole point of the exercise, to constrain the mating distance, to make sure that mating isn't completely random anymore. And then once we have picked a random mating individual, then the two individuals should create a new genotype, new offspring genotype, and that new genotype should then replace the old genotype. So there's one small issue that I would like to talk about first before we're going to go ahead and implement this code. And here's what this issue is. So if you think about our grid like this, and now you think about some individual. Let's say we're currently here at this individual, and let's say we have a mating distance, max mating distance of 1. So this would be the mating neighborhood here. And now, just for the purpose of this code, we're actually going to include this individual. So self-mating is going to be possible, but that's not a big issue. But all these cells here now are possible mating partners. Okay, so let's say our random algorithm picks this individual here, down here, as a mating partner. So now these two individuals mate, and they create a new genotype that I'm going to denote here in blue. And this new genotype should replace the old genotype here, because it's a new generation. Now, where I have to be careful is, if I'm just going to go ahead and replace it right now, just overwrite this genotype here and replace it with this new one, then there's a potential issue here, which is the following. So now imagine I'm going to go, now the algorithm says, okay, I'm done with this individual here, I'm going to go to the next individual. Now, let's say, for example, this individual could now pick this individual over here, just by chance, as a mating partner. Because the mating neighborhood now for this individual is this area here, right? Just shifted by 1 to the right. And so this individual over here in blue is included. And so we might just by chance pick this individual as a mating partner. Now what would happen though is something that shouldn't happen, which is that this individual here from the current generation will mate with an individual from the next generation. And that's not supposed to happen, right? All the mating should happen within one generation, and then the offspring should replace the old generation. But if we just do this sequentially, there might be many cases where an individual reproduces with an individual from the next generation. So the trick, what we really want is, we sort of want to place all the offspring individuals on a temporary grid where they will be waiting. So this would just be the same grid, same dimensions. It would be a different grid, but it would have the same dimensions, and we would put the offspring here, at the corresponding location where they will live in the future. And once we've done this process, we've gone through all the individuals and picked the mating partner and put their offspring individual here, then we're going to go ahead and basically just replace the original individuals with the offspring individuals. So what we need is, in addition to this grid, we need some form of temporary grid where we can place the offspring, and then once this process here has run its course, we're going to essentially replace the entire generation here with the offspring generation. And that helps us avoiding this issue of mating across the generations. So let's go ahead and do this. This is actually quite simple. So we're going to go through all the elements in the grid. So again, we will want to have this two-dimensional loop. But first, what I'm going to do is I'm just going to set up this temp grid variable here. And now I can essentially just do the exact same thing here. So I'm going to take this for loop here for var I equals 0, I smaller than grid length, I equals I plus 1. And then, of course, I'm going to have a second loop var I smaller than grid length. So I want to go through all the individuals. But here, just like before in the init grid, I have to initialize the temp grid I array. This makes sure that we actually do have a two-dimensional temp grid. It's just the exact same process as up here, right? Exact same logic is going on here, just with the temp grid. All right, so now I'm here at this, a given individual at grid I. And what am I supposed to do now with this individual? Well, first I need to pick a mating partner. Okay, so how am I going to do that? Well, I think I'm just going to hand off this responsibility of picking a mating partner to a new function. So what I'm going to do here is I'm going to call a function pick mating partner. And once again, I haven't defined this yet, but this is how I want it to work. And I'm going to pass just the coordinates. That's all this function needs. Because grid is a global variable here, and all the functions will have access to the grid. So they just need the coordinates here. Now, this function will return, or should return, a mating partner. So I'm going to store this here in a variable called mating partner. So pick mating partner should return a random mating partner from the allowable mating neighborhood. And then once I have this mating partner, I would like to create the offspring. I would like to get an offspring individual from the current individual here at this location I, and the mating partner. So let's just define a function that does that. It's called getOffspring. And I'm just going to pass in the individual. And again, you could in principle write this as just passing in the coordinates, but here I'm going to pass two individuals just for consistency. Mating partner. So this function will return a new offspring genotype. And where would I like to store this offspring genotype? Well, exactly as we just discussed in temp grid at this location. So temp grid I will now contain the offspring individuals of these two individuals. Okay, and need to make sure that I'm closing the for loop here. So now that I've done this, once I'm here and I've gone through all the individuals and I've picked a mating partner for them and I created an offspring individual and put them on the temp grid, now I need to make sure I replace the original grid the individuals on the original grid with the temp grid. And one easy way to do this is to just again loop over the grid. Whoops, I wanted to copy that. Loop over the grid. So just like here for var I, and then the second level will be for var I. And basically here in this two-dimensional loop, I'm going to say I want to store now in grid, so I want to replace grid I with whatever we have at temp grid I. And this now basically, places this value here into grid I. So that's the replacement step here. And then since I have a generation counter here at the end, I'm going to make sure I'm going to up this by 1. So I'm going to increase this value by 1. Oops, plus 1. And that's it. So we now have our run generation function implemented. What's missing now, of course, is our pick mating partner function and our get offspring function. And we will implement those in the next video. So see you in the next video.